All right, let's jump right in. You know, we always see these huge headlines about mega projects changing the world, right? But the real story, the really fascinating stuff, is often hidden in the tiniest little details. Today, we're going to look at a small piece of engineering that is quietly stopping catastrophic failures inside some of the biggest, most ambitious construction projects on the entire planet. So to really set the stage here, you have to understand the scale we're talking about. Countries like Saudi Arabia and the UAE are pouring hundreds of billions of dollars into their water infrastructure. And this isn't just some side project. It's a central part of their massive national plans, like Saudi Vision 2030. This is all about securing their future. I mean, think about it. This is one of the driest regions on Earth. Getting a steady, reliable supply of water isn't just a priority, it's a matter of survival. And the answer, for them, lies in these enormous desalination plants all along the coast, basically turning ocean water into fresh water on a scale we've never seen before.
And this gives you a sense of just how massive this operation is. These aren't just pipes. They are literally thousands of kilometers of life-giving arteries, pumping water to build the cities of tomorrow. The reliability of this network, well, it's everything. But there's a hidden weakness.
And this, right here, is where we meet the villain of our story. It's a tiny, easily overlooked detail that has the potential to crumble these billion-dollar investments. And that villain is rust. But trust me, this is not just any old rust.
The atmosphere in this part of the world is officially classified as CX, which stands for extreme. Just try to imagine a constant, invisible chemical assault. You've got intense heat, humidity that's nearly 100%, and air that's just thick with salt from the sea. It literally eats through normal metals in no time at all.
So in this whole massive network, where's the most vulnerable spot? It's right here. These simple steel bolts, they're called tie rods, that are used to clamp traditional pipe joints together. They're sitting right out in the open, completely exposed to that brutal, corrosive air 24/7.
You know, the traditional design is just fundamentally flawed for an environment like this. Every single bolt is a potential point of failure waiting to happen. The whole thing creates this bulky cage that takes up way too much space in already cramped pump houses. And the worst part? When you need to do maintenance, those nuts are often rusted so completely solid that crews have to come in with blowtorches and literally cut them off. It's a nightmare.
But what if you could just get rid of that weak link entirely? Just eliminate it. Well, that's exactly where this brilliant piece of German engineering called FlexPass comes into the picture. It completely rethinks the whole problem from the ground up.
The magic is all in what they call the internal locking principle. So imagine a set of interlocking teeth inside the joint that grabs onto the pipe from within. This patented design takes all the pressure internally, which means there's absolutely no need for that external cage of bolts. It's a total paradigm shift. No external parts means there's nothing left outside to corrode. And the difference is just, well, it's night and day. On the left, you've got the old way. It's cluttered, it's vulnerable, it's bulky. And on the right, the new way. It's clean, it's compact, and it's completely sealed off. All the important stuff, the structural integrity, is safely protected on the inside, instead of just hanging on by a few rusty threads on the outside.
The material itself is also a huge upgrade. It's made from this special V4A stainless steel. And what's amazing about it is it has something called a passive layer, which basically means if it gets scratched, it self-heals and makes it totally immune to rust. It also gets rid of another massive problem called galvanic corrosion, which is a nasty reaction that happens when you connect cheaper metals like cast iron to these high-tech pipes.
Okay, so the design is way smarter and the material is better. But what does that actually mean out in the real world, on a job site? Let's look at a head-to-head comparison of a really common maintenance job.
So, picture this. A critical valve in the system needs to be replaced. With the old system, after a few years, those nuts are rusted solid. You need a whole crew with cutting torches and sledgehammers just to break it free, and you destroy the joint in the process. We're talking 12, maybe 18 hours of downtime for the whole plant. Now with the new system, you just release the internal lock, and that valve is free in under 2 hours.
And what's the big deal about a few hours of downtime? Well, for a massive desalination plant, every single hour it's not running can cost over $50,000. So that 10-hour difference we just talked about, that saves over $500,000 in one single maintenance event. All of a sudden, the higher price for that advanced part doesn't seem so high anymore, does it?
And if you look at the raw specs here, it's just no contest. Check out the pressure rating. FlexPass can handle up to PN 100. That is 4 times higher than the conventional standard. And maintenance?
The old way needs constant checkups and retightening of bolts. The new way is literally fit and forget. You put it in and you're done. Oh, and here's another total game changer. Installation time. An 80% reduction. On a mega project where you're installing thousands of these things, that adds up to saving hundreds and hundreds of workdays. That's what keeps these massive, time-sensitive projects on schedule and on budget.
So let's zoom back out for a second. What this little ring really enables is a fundamental shift in how we think about building and maintaining our most important infrastructure. It's about moving away from a mindset of constant repairs and breakdowns and moving towards one of built-in, long-term, absolute reliability. I love this slogan. It really says everything you need to know. No rods, no rust, no regrets. You get rid of the rods, which are the main point of failure. When you do that, you get rid of the rust. And the result for the engineers and the operators is a solution with zero stress and zero regrets.
So you see, at the end of the day, this is so much more than just a better pipe fitting. This is about making sure these massive national investments are actually viable for the long haul. It slashes operating costs, it makes the whole system safer, and it actually makes the futuristic vision of a fully automated city like NEOM possible.
It really makes you stop and think, doesn't it? As we're building these incredible new cities and technologies for the future, what other small, almost invisible innovations like this are the true heroes of the story, quietly solving billion-dollar problems we never even knew existed?